There we go. Okay. An equation that is true for all real values in the domain of the variable is. Oh, let's see. Okay, so this is what I was talking about, number three. Um, you're really just plugging in one little piece. You're not really working it out. So make sure you write the problem, right? You want to start with this, and you want to figure out, okay, what do I change what into, right? Do you see what they chose? Because they're trying to make this turn into one. So make sure you pull up your, let me go ahead and pull up mine too. The identities. Hopefully they're still here somewhere. Yeah, here they are. Okay. So notice that they're using the tangent identities, sometimes called the ratio identities. Sine over cosine, cosine over sine. So they know that they're going to cancel. That's why they chose it. Because it needs to turn into one. Okay. So if you didn't have that hint that they gave you, I would want you to start like this on an exam. I'm going to use X. When proving identities, you want to choose a side and solve it. Those will become cosine X over sine X times sine X over cosine X. So I chose the left-hand side because I don't know how I'm going to deal with that one. So I chose the left side. Well, I guess, I'm sorry. On an exam, this is what I want you to do exactly. You first choose the side. Then you choose the identity you're going to use. We're going to use. In this form of the page, they call it tangent identities. Okay. So you can see that they're going to cancel. When everything cancels, you're left with the one. So here we used identity. It's also called tangent. But the homework, all they want you to do is follow along. Like, all right, well, we did everything for you. What goes here? Now, there's not much to do on the homework, but I want you to get in the habit of doing it this way. Okay. That's more like what you're more what the chapter is about, 7.2. And it's kind of what you're going to see on the exam anyway. Eventually, they're not going to tell you what to do. I mean, in the homework. I'm thinking the first few problems are just going to be kind of filling in the blanks. But if they're all like that, make sure, no matter what, you just work about it. Right? Does that
For
make
number,
sense?
yeah, for number 4, would it be the sum and difference formula that we would convert it to?
Let's see here. So you want to prove that the left-hand side is equal to the right-hand side. What side did you choose?
Cosine?
The
Oh, the
left.
right side? Oh, the left side, sorry, yes. I thought you said what sign.
Oh, what side? So let's go ahead and move on to the next one then. Okay. So I'm going to choose the left-hand side, like you said, because you usually want to choose the most complicated side. And you can see they kind of already hinted at this. Okay. Do you see that there's a difference of squares?
Yes, with the 1 plus cos and 1 minus cos, it's sine too. The difference of squares right there, right?
Yeah, it's going to be equal to what? Do you guys remember?
Would it be
What's missing?
and
The
then
square
1?
on the outside of cos.
All right, we said difference of squares, so we need the squares, right? If you multiply it out, you can do all the work if you want, but you're not going to end up with this. But if you see that it is a difference of squares, then just use the formula, jump here to the difference. Does that make sense, or is that weird?
Can you say that one more time?
So you could multiply this whole thing out, right? 1 times 1, 1 times cosine. Cosine times 1.
Yeah, I got the
Oh,
answer.
like the foiling?
Yeah, you can FOIL this out however you want to do it. But if you notice that this is a difference of squares to begin with, then just jump to here using the formula.
Okay, got it, got it.
I got the answer right on the homework, but it says I got it wrong. So I must have input something because I put cosine squared with the a.
Yeah, it should be squared in here. You're talking about this part?
Yeah,
Should be cosine squared alpha.
yeah, that's what I put, and it says that it's wrong. But it's giving me the answer that it is right, but I don't know. Oh, I think I put a. I should have put alpha, right?
Yeah. Okay.
Like with the Greek. Let me see.
Yeah, Greek kind of likes their Greek letters. Okay. But do you see where we're going with this? What is 1 minus cosine squared? If you look at the formula sheet, You guys have your sheets open?
Yes, and yeah, it was the lettering. I should have used alpha instead of the letter A.
Yeah, it happens. See, it's gonna be one of these guys, right? So if you solve for cosine, we get 1 minus sine squared. So then delete everything. So that's why this part is equal to sine. So like if you didn't have this whole big hint right here, you would have to choose either this side or this side. And then try to get to the other side. Okay. You would end up with, we just go through it one more time. It's real quick. Right here, we use Pythagorean identity. Okay. Anyway, does that make sense? What we did? Sorry, I got distracted.
Yeah, that makes sense. So number 5 would also be Pythagorean. We could use that for the first choice.
Number 5. Yeah, it looks like they are changing this guy into 1 minus cosine squared theta. Then you distribute the 3 and you're going to get 3 plus. Wait a second. Pretty sure this is this. So then if you distribute, oh yeah, I see. So this -3 times the -1 is this one. -3 times a cosine would be 3 cosine squared beta. 3 plus 3 is 6.
I see. But in the test, we would have to show.
Yeah, in the test you're gonna get something like this. That's it. You need to choose a side and figure out how to get to the other side. I'm not going to give you any hints or anything. Just, all right, well, we'll start here. How do you get there? Or vice versa. That makes sense?
Are you going to require us to write the identity down, like next to the problem?
No, but that would be helpful while you practice, but I won't require it. That's up to you.
Thank you.
Any other questions on 5? Okay. Guys, you good then? The all length is, let me see. It looks that way. That's what I advise you to do. Because they're all the same. They're not. What I recommend when you start these problems is write this first line and choose a side. And just try to work on your own without looking at what they did. You can look at what they did for hints as you practice and get used to it, but remember eventually you won't have those hints. Okay? Does that make sense? Write it out, do each step yourself, and then come back later and fill in these weird blanks. Okay. All right, so let's pick this guy. We're not gonna look at what they did. I'm just gonna pretend that it's visible. I don't know what that is. So which side should we choose? I don't even know if the left side is a good one. Right, rule of thumb is you want to choose something that's difficult or ugly looking. All right. It looks like we're trying to go from sine to cosine or cosine to sine. So I think both sides have similar difficulty. I don't think we can go wrong here. So I'm just gonna choose the left just cause. How do I get to cosine? So what would you guys try?
The Pythagorean identity of sine. So 1 minus sine squared.
Yeah, we could do that. Although, do you guys see anything in common with this before we do the Pythagorean? And they both have what? 7 in common? And a sine squared. See what I mean?
So we factor that out.
Yeah. Factor it. Okay. What is now let's do the Pythagorean. What is sine squared equal to? This piece, right?
Sine squared is equal to 1 minus cosine.
Yeah,
Squared.
so we can switch that to cosine because we want nothing but cosine. So go ahead and apply your identities. Uh, 1 minus sine squared. That's gonna be what?
What was the question?
What is this piece gonna be?
Would it be cosine? Also?
Yeah. Okay, so we got what we wanted. So now do the multiplication. So cosine times these two would get me cosine squared minus cosine to the fourth. Is that what we wanted?
Yes.
Yeah.
Mine's a little different. Mine, instead of the 7, it's 8, but it's the same answer.
Oh, they just had an 8 instead.
Yeah.
Yeah, it's all the work would be the same. Okay. So you get the idea on how to approach these. You choose a side and get to the other side, using all those identities on the page. The homework is going to give you a ton of hints, so use those hints at your discretion. Any questions on 6?
I did have a question. So the second parentheses down at the bottom, it's the cosine squared minus the cosine to the fourth. But the one right above, why is it those two squared and not like the fourth?
Oh, well, it was kind of weird, I guess, but I distributed this way.
Oh, okay. Okay, that makes sense then.
And then I did the 7. Is that all right? Or?
Yes, yeah, it makes sense.
Okay. And any other questions? Okay. Well, let's move on. Out. How's you good? Pretend I can't see that stuff. All right. I'll look at time. So, remember we said a good rule of thumb is choose something that looks more difficult to start with. Do you guys think the left is harder looking than the right, or more challenging to deal with? Or is it right?
Yeah, the left, because I don't like fractions.
Yeah, I think that's a good way of thinking. It looks crappy. I hate fractions. I should choose that. Okay. So I need to get to the right side. Actually, maybe this is not too bad after all.
So with that, would you basically just multiply the numerator by the denominator to get rid of the fractions?
You could, you're talking about do the LCD to add them? Or what do you mean?
Can you say that again? I can't hear you.
We can't multiply both sides because we only have one side to work with. We can only multiply top and bottom of one fraction or top and bottom of the other. That's all we can do. But look at the formula sheet. There's that little step there, but wouldn't we use these instead? Maybe we're making it harder than it needs to be. This is almost what we have, right? Except there's a 2 on top. You guys agree? Yeah, the reciprocal identities, that's right. So
Yes.
just pull out the 2 in front and just check this out. Right? What is 1/10? This is
Cotangent.
cotangent. And then this guy. Tangent. Reciprocal identity. Isn't that what we wanted to show anyway? So the method I use is not what they did, is it?
Yeah, it looks like they just added the top and multiplied the bottom. Oh no, wait, no, they multiplied both. The reciprocals. I see. The way they did it's a little different. But it's the same, right?
It looks
They just multiplied the 2 on top of the tan by cotangent, and then the 2 on top of cotangent by tan.
Oh, you mean they added the fractions, right?
Yeah, they added the fractions.
I see. Yeah, it just looks weird how they wrote it. But that's the only way they could get that. Oh, I get it. Yeah, yeah. So this is the tan. Once you add your fractions, LCD is right here. So once you introduce it, you'll get this on top. And this, you should have 10 cotangent at the bottom. I see what you're saying. Then these would cancel, leaving with a 1, getting into here anyway. So if you were to add these instead, you would get what they got. Just by doing fractions. Or you can use the reciprocal identities. There's more than one way to do these. It's just that the way these problems are presented, they kind of lock you into one method. Okay. Anyway, any questions on 7? Good. But so leave the rest to you. End up doing all of them for you. Try working these out. And if you have questions next time, I can help you out, because I know they can be difficult and it's a different way of thinking, because we're not solving for anything, we're just trying to prove a statement. Right? So you start on one side and you use all your identities and formulas and your algebra skills to get to the other side. So it's like a weird game. If you know all the rules and the game's fun. If you struggle with the rules and don't remember the steps, then the game is horrible. All right. You guys have any well, let's stop the lecture here for today. Do you have any